And one thing they saw that really screwed things up was this. Like, imagine you were tracking the planets. Okay, let me get a blank space down here. Imagine you were tracking the planets, and these were the background stars. Okay, and let's say, oh, I froze up. Let me just reboot that. There we go. So that's the background stars, and you were going to track the planets from day to day to day to day. And let's say you were tracking Mars, for example. If you tracked Mars, and if this was how you thought things worked, Mars would just spin around the Earth in a simple circle. And so if you were standing on the Earth looking up, that should mean that Mars should go across the stars in a perfect straight line, right? You would expect Mars to go across the stars like this. Maybe it's here in January, and then July. Sorry, what's the month after January? January, February. Basically, it should go across the stars like this. January, February, March, April, May, June, blah, 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 blah. Nice straight line. But if you really watch Mars every single day, every once in a while, this is going to happen. Check this out. Let me zoom in a little bit. Here we go. For a few months, it'll go one direction. So January, February, March, and then, for a little while, it'll actually turn around and go backwards across the sky for a few months. And then it'll turn around and go the main direction again. So most of the time, Mars goes one direction across the sky. But every once in a while, for a little bit, it'll turn around and go backwards, okay? And we call that retrograde motion. And Mars is not the only planet that does it. So here we go. Retrograde motion. That's when a planet looks like it goes backwards for a little while. Okay? So the ancient Greeks had to figure out, how do we explain this? How do we get Mars to go backwards in our system, right? And that was hard for them to do. It was hard for them to figure this out. And the person that figured it, the first person to come up with an explanation for this, which we now know is wrong because it's based in the ancient Greek system, but the first person to come up with an explanation for this that worked, sort of, was a guy named Ptolemy, okay? I'll write his name down. Ptolemy. And by the way, the P is silent. So when you're saying this guy's name, it's just Ptolemy, okay? Just Ptolemy. This was an ancient Greek. He was a mathematician and scientist. And he came up with a way to explain retrograde motion. Okay, so what did he do? He kept the Earth in the center, so right off the bat we know he's wrong. But the ancient Greeks were pretty sure that the Earth wasn't moving. So let's keep the Earth in the middle. I'll put a little E on it for the Earth. Okay, and he kept a glass ball for every planet. Every single planet still had a glass ball. I'm just going to draw it for one planet, but every planet had another one of these, okay? Now, remember, in the old system before Ptolemy, the ancient Greeks thought that the planet was attached to this ball and that ball just spun, okay? Here's what Ptolemy added. He added a second glass ball. He attached a smaller glass ball to the big glass ball. And he said that the planets were attached to one of those. So each planet had one big glass ball, and one smaller glass ball on it that it was actually attached to. So that little dot, that might as well be Mars, okay? And he called this extra glass ball an epicycle. So his explanation for retrograde motion was epicycles. Now, how does this fix things? Well, here, in his version, the big glass ball stayed still, and the little glass ball rolled on the big glass ball, okay? Like a tire. Like, imagine that this ball was a tire, and that Mars right here, this little planet, is like a nail in the tire, okay? Now, if we do that, and this ball is allowed to roll, what's going to happen? Well, when Mars is on top of this little ball, it's going to roll forward. But which way will Mars go when it spins down to the bottom of this little ball? Which way will Mars be going? It's moving forwards when it's on top of the ball, but which way will it move when it gets to the bottom of the little ball? Backwards. Yeah, it's easier for me to show you guys a picture from the book for this. Get right here. There we go. So on here, as the little glass ball rolls on the big one, every time the planet moves underneath the tire, it'll move backwards for a little bit. Every time it moves under the tire, it moves backwards for a little bit. So in our little picture that I was drawing, what's going to happen is that as the planet goes around the Earth, it's going to loop underneath like this over and over again. So instead of going around the Earth in a perfect circle, it goes in a curly-Q shape, right? Like spaghetti, right? And that way, if you're underneath this part, it's going to look like the planet's going one way, but if you're underneath that part, it's going to look like it's going backwards. So every once in a while, it'll go backwards, forwards, backwards. And that, people were pretty satisfied with that explanation because it didn't throw out the whole system, but it still could show the planet going backwards sometimes. But here's the thing. We got better at mapping the stars, okay? We got better at mapping the stars. And if this is what's happening, if this was right, let's say it took 5 months between this retrograde motion and this retrograde motion. If there was 5 months between this retrograde motion and this retrograde motion, when would the next one happen? When would the next one happen? If it took 5 months from that backwards motion to that backwards motion, when would this next one happen? Don't overthink it. 5 more months. Yeah. And then 5 more months to the next one. And then 5 more months to the next one. If this was the whole explanation, then, and that ball spun at one speed, which that's what they assumed was happening, that meant that the retrograde motion should always happen like a clock. It should always happen in the same amount of time. But as we got better at mapping the stars, we realized it was irregular. It didn't always take the same amount of time to start going backwards. And so what they had to do was tweak it again, okay? They tweaked it another time. So here we go. So how did they fix it? They still had the Earth in the middle. They really loved that part, and they're still not figuring out that that is the reason they keep having to fix the problem. That's the problem that they haven't realized yet. But how did they fix it? So they still had the glass ball for each planet. They still had the epicycle that was rolling on it. But the planet wasn't attached to that. The fix was there's another glass ball on that glass ball. And that's what the planet is attached to. So the littlest glass ball can roll on the medium glass ball, and the medium glass ball still rolls on the big glass ball. So now the planet goes around us like this. Okay? Yeah. So this is something, right? This is something. And it was more accurate at predicting when retrograde motion would happen. It was more accurate at predicting when the planets would go backwards. Until they got better at mapping the stars again. And so they had to tweak it again. They had to tweak it again after this. Anybody want to guess? Let's guess here. How did they tweak it? What did they add to this to try to make it more right? What was the next tweak? I bet you can guess. More balls! Greeks add more balls. There we go. There's another ball. And that worked a little bit better, but it didn't work perfectly. So they added another ball, and they added another ball, and they added another ball, and another ball, and another ball. They added between like 20 or 25 balls to each stack. And the planet was attached to like the very top of that stack. And so this whole stack was just swinging around. Big stack of balls, just whoa! Tons and tons of glass balls. Somebody stole the joke that I usually make about this. It's like total ballception. Total ballception here. And here's the thing. Mars was not the only one. And that means that the planets were going around the Earth like a crazy mess. Like the path of the planets was just ridiculous. And at this point, people were like, is the solar system really this complicated, right? They started to realize this was a little bit wrong. Also, check it out. If these things are made out of glass or crystal, and every single planet had a giant precarious stack of them that they're all swinging around like crazy, what could happen if that were true? If every planet was swinging a tall stack of glass around, glass or crystal? That would be a big problem. Yeah. It could break, right? It could break. If this was how things were set up, if those glass stacks got too tall, they could slam into each other and then break. And then if they broke, the planets would fall onto the Earth. At least that's what the ancient Greeks thought. So around this time, people were starting to think, maybe we're like going in the wrong direction with this whole thing. Unfortunately, I think they would have maybe considered going back to the heliocentric model at this point. But before they could come up with that idea, their society collapsed. Okay? Greek society and fell apart. And things were on fire. Not because of this. It was for other historical reasons. Take a history class for the details. But if your society is on fire, are you probably going to worry about this? Are you probably going to worry about why the planets go backwards sometimes in the sky? Is that going to be top of your list of like worries under a collapsing society? No. At that point, your job is just to survive again, and so probably you didn't worry too much about explaining the sky, right? Actually, most of this information may have been lost to us forever. Society collapsed really bad at the time. Things were burning, libraries were burned down. Most of the information was lost in Greece itself. The only reason we know that the ancient Greeks thought any of this is that before their society collapsed, they visited the Middle East, some of their scholars, and some of the scholars from the Middle East actually visited Greece as well, and there was cultural exchange and idea exchange. And so luckily for us, libraries in the Middle East where society wasn't collapsing, they were able to hold on to all of this work and actually improve on it over time. They were able to, in the Middle East, to make better and better star charts over and over and over and over again. Who forgot to write down the ball theory? They wrote it down, and it was saved. If nobody wrote it down, we wouldn't know it today, right? Now, check this out. So we're gonna kind of skip forward a lot in the timeline here, because not a lot of work was done on this for hundreds of years after the ancient Greeks, other than people making better and better star charts and having to make tiny little tweaks like this. But nobody was interested in changing the central problem, which was that the Earth's just not at the center.